Hi everyone, today is June 29th. Welcome to Konveyor community meeting. We abide by Konveyor code of conduct, which means please be nice to one another. This meeting will be recorded and available on YouTube for later viewing. All right, so does anyone want to say hi? Do we have any new members? All right then. So the first up on agenda is a demo. There are two demos. The first one is from me, so I'm gonna dive right into it. Right, today we are going to see how to modernize the Petclinic application to Kubernetes using Konveyor. As you all know, Konveyor is really good at surfacing information and insights that can assist enterprise architects, migrators, developers, whoever is responsible for the migration journey to come up with informed decisions about the migration itself. So what we're going to see in this demo is leverage the learnings that we learned from a failed migration of the Petclinic app to Kubernetes, take those learnings and knowledge and convert it into custom rules and target, and integrate the custom target with Konveyor, which can then be used to identify similar issues in the future migrations. So before I dive deeper into the demo, I want to pause and give a little bit of background about the application itself. This is a famous Spring Framework example called Petclinic, and this app has been taken and modified to mimic a real-world scenario. So the modified version uses Spring Session Management for managing the user sessions. The Spring Session Management assists with clustered sessions. That means that we can run more than one instance of Petclinic application, and all those instances can share the same session store. That means that if one of the application's instances goes down, we have the continuity in the user sessions. So, and we use Hazelcast to as a backing store for the session. Hazelcast is a very widely used enterprise distributed cache management. So we have included that in this demo to provide an enterprise feeling. All right. And this is the pictorial high level view of the setup. So in a real world, it would actually be like much more, it will have much more complicated components and whatnot. This is a simplified view just to provide an idea of how the Petclinic application would be deployed in a traditional setup. So there is here this is the load balancer web server, whatever that you like to call it. I just say it's load balancer in this case. And two instances of Tomcat, each running its own, each has its own Petclinic app instance. And each of the Tomcat actually spins up a Hazelcast member. And these members actually join together to form a Hazelcast cluster. Hazelcast has this auto discovery mode that can help with finding members as and when they join in, or if they are the given, if they are there in the given environment, they will pull together, they'll make a cluster. And that is what is used as the session backing store. So you get the same, the session ID is shared between multiple instances, and you get the same session ID throughout the experience. And that seemed very simple, right? So let's move on the next step. So what I thought is like, it should work. It's already working in a Tomcat container. It's all like in a package. So what I did was like take it and put it in a Docker container, deploy that to Kubernetes, and prayed and hoped it'll work. Let's see actually what happened. So I've already deployed the Petclinic app to Kubernetes. So in a minute, I'm gonna get the ingress and navigate to the web page, and let's just hop around this website. And what we want to see is that we want to see uninterrupted user session, which means that we want to see the same session ID here as we navigate through the web page. Um, But what we get is that the session ID keeps change. It's gonna keep changing. Oh no, sorry about that. I don't know. It decided to. Anyways, back to the demo. So it's gonna keep changing as we navigate through the this application. And in a minute, we will see why. So if we so there are like three replicas of this application running in Kubernetes, and so naturally there should be three Hazelcast members. But when I take a look at the logs, what I saw was that each of the Hazelcast members has formed their own Hazelcast cluster. Instead of joining together, they just don't know that there are other members in the cluster, the Kubernetes cluster that exists. So they made their own Hazelcast cluster, which means that they are each of them have their own session. Each of them act as a session backing store. So every instance has its own session backing store. We'll see in a minute a representation of how it looks. So this is how so the deployment to Kubernetes looks like this. So we have like an ingress, a service, three instances of the application. Each of it has its own Hazelcast member. But what has happened is that they have not joined together to form a cluster. Instead, they are their own cluster. And so each of them is actually when you navigate through the application. So since we are using Nginx Ingress, it by default it's gonna round robin the request across the parts. So every time it's the request is going to a different part, we are getting the different session. That's why we are seeing different sessions. Um, oh, I shouldn't have gone back, but yeah. Anyways, so let's take a minute and I want to walk through as to why this is happening. First, like I explained, the first thing is that the clusters, the ASIC class cluster is not getting farmed. And I was like digging a little bit deeper, and then I came across two things. One is that the dependency that's being used in the modified version of the Petclinic app doesn't know there is something called as a Kubernetes environment. So naturally, it doesn't have support for Kubernetes environment at all. And the second one is the discovery method. Like when I explained that how Hazelcast members can, um, as and when the Hazelcast member joins or leaves the environment, they can join together to form a cluster. That is the auto discovery mechanism, and that mechanism that's being used is not supported in Kubernetes. Um, So these are the two main issues that I identified, and this is like, in order to solve it, need to upgrade the Hazelcast dependency naturally, and also like have a method that would support our work in Kubernetes. So the next step is conveyor analysis. In this step, what we're gonna see is I have taken those lessons learned and converted them into custom rules. And then what I'm gonna show is I will show how to create custom target with those rules and integrate it with conveyor and run through the analysis of the Petclinic app using that custom target. So here's a brief overview of the two rules I have added. And one is like, okay, you encounter certain version of Hazelcast, then alert telling that you need to upgrade the version to a version that is supported, knows the version that is aware of Kubernetes. And the second rule is that, okay, use a different discovery mechanism so that it can work in Kubernetes. For some reason, it doesn't even want to play. Okay. All right, so this is the overview of the rule. So here, it's a very simple XML format, and the future versions of Konveyor will be supporting YAML format. I think it's going to be supported from 0.2.0 if I'm not wrong, but I can check back that check on that later, an update. So it's a very simple format, and I have a target technology, and I've said like cloud readiness because I want to successfully migrate this application to cloud, or in this case, Kubernetes platform. So the target technology is obviously cloud readiness, and there are there are two rules. And the first rule is going to say like, okay, if you encounter there's two methods which are not going to work, it can be made to work in Kubernetes, but it needs many other complex architecture or deploying this app as stateful set. For this demo purposes, I have excluded all those things and considered very simple solutions. So I assume that if you encounter these two methods, this add a note telling that, okay, this is a cloud mandatory issue. If it needs to be working in Kubernetes, then it should use this method, which says like enable the Kubernetes configuration method. So that is the first rule. And the second rule is if the dependency version of Hazelcast jar that we have in our project file, the pump file, if it is falling between this version 2.0.0 or 4.2, between 2.0.0 and 4.2.7, then add a message telling that please update it to 5.0 or above. So very simple to write. And let's go back to the Konveyor dashboard. So if you have used Konveyor dashboard, you would have seen two views. One is the administrator view, one is the migration view. So what I'm going to do first is that I'm going to go add a custom target. And so in order to do that, go into the administrator view, click on the custom migration target. And I'm so sorry, my network is really bad. So it's switching the quality of the video. Just bear with me for 1 second so that it's visible clearly. Okay. So I have already created my Hazelcast session management target, but you can easily create it by clicking on this button, create new. There is a wizard that will walk you through the process. But quickly, I'm going to show how it actually looks. So this is like the basic information, add the name, some description to which is like makes it informative about what the target is. And then I have downloaded the file that I showed and uploaded it here. Make sure that you have this extension if you are using the XML format. And once it's done, click on save and you're good to go. And let's go back to the migration view, and I'll configure the Petclinic application. So in a minute, we will see how I have configured it and then run through the analysis. I have used Git as the repository type, and I have configured it from my Git repo. I've said that, okay, this is the repo and this is the branch, and that's it. So it's simple. Save it, and then let's run it through analysis. This is the analysis wizard that opens up. People might have different name. I just call it a wizard. So if it is a different name, please let me know. So obviously, I want to click the source code. I just put the Git repo in, so I'm just clicking the source code here. And you can also run it with dependencies, but in order to avoid extra noise in this demo, I just selected the source code and click on next, and then here. So all the targets are going to show up here. The ones that comes pre-configured, the ones that we just added, like a custom target. And if it's a custom target, it's going to have this nice little tag on the top, so you know that it's custom. So what we're going to do is, obviously, I want to migrate Kubernetes, selecting containerization. And I am going to select Hazelcast management target as well. So you can select as many targets as you want, as long as it makes sense. So that is really cool. And click on the, I get the defaults, and I'm gonna quickly review. Okay, everything looks good. So click on run. And here's a neat thing that I learned. So I wanted to include that in the demo. So I was debugging, and one of the engineers, Jeff, actually showed it to me. So you can click on this kebab, little kebab here, and then click on learn the analysis details. This actually comes in handy when you don't have access to the parts, or you don't want to go to the cluster or command line or anything to know what is actually happening. So you can actually see what is happening in the analysis phase, or what the pod is actually doing. Here it says running. So you can refresh this page to know when it updates. It's really good at putting the status here. If there is an error, it's going to throw the error here. And if you're impatient like me, you're going to constantly want to refresh. So I forwarded that. So it takes about 2 to 3 minutes to run analysis, depending on the size of the application. Sometimes it can take 10 minutes, 2 or 5 minutes, and also depending upon the resources in the cluster. So it has succeeded. And let's head back to the analysis tab and go through what we have found. So here in the side pane, you can see like multiple things. One is the detail, another one is tag, another one is reports. And I want to take a minute to talk about tags. So as the analysis module was running, it identified certain technologies that is present in this Petclinic application, and it has tagged it accordingly. And this comes handy when you want to group some of the applications together, or if you want to filter based on tags. It's really powerful, and it's a cool thing. And let's now I'm going to move on to the reports. Click on the report. It's going to open a dashboard, and this is the or a high level view. So this has many charts. As you can see, it's gonna provide some information on how many incidents, and on what category, how many incidents, and then like the story point estimate. And the one that's concerning, we are concerned with right now, is the cloud mandatory one, because we want to migrate to Kubernetes. So we have 8 incidents and 12 story points. Um, it provides a cool high-level view and a nice chart for the managers who like charts. Um, so the next is the issue tab. So you can, in order to learn more, go to the issue tab. In the issue tab, all the incidents that we saw would be like populated. And like I said, we are concerned with the cloud mandatory ones. The first one is a file system jar.io, what means that it found some entry of reference to a local file system. So there are like 5 incidents found. I'm not going to go into that. I'm just going to focus on the Hazelcast here. And the first up is that it found embedded Hazelcast. That is the rule description that I provided there. And it says like, okay, in this file, there are 2 incidents found, and this is a solution. Please update the method to Kubernetes aware. So let's take a look into the file itself and see where the issue is happening. So my rule is very simple, no rejects magic. So I just said that if you encounter multicast config or TCP IP, then suggest this message that it needs to use Kubernetes aware. We can add like complex rejects to even filter out, telling like only display this rule if it is enabled to false. But for this demo, I haven't gone in the complex rejects. So it's simple. Even though it's set to false, it's actually like displaying, okay, this is what you have to do. The beauty of it is that the migrators, the architects can actually go into this and take a look at it and decide that if they want to actually act on this rule, or actually do something about it or not. But it provides all the information, which is really cool. Uh, so let's head back and take a look at the next one. The next rule is the dependency rule. So I'm going to go into the, it says like in the PALM file, it has found 1 incident, and it says that update the ASLCast version. And let's head back to the PALM file and scroll through, and here is where it found the Hazel found the violation. It's printing that you have to use Hazelcast 5 or above. And I'm gonna quickly show the Hazelcast version that we are using. It actually took me a minute to find where that is, but it is here. But when I was recording, it took a minute. We are using 4.2.2, so obviously it's saying that please use 5 or above. So what we have seen is like we have seen that okay, there are like few cloud mandatory issues that needs to be addressed in order for this application to work fine on Kubernetes. What I've done in the background is I have taken the suggestions suggested in the by the analysis module result and taken that, incorporated that in the source code, packaged it, and deployed it to Kubernetes. And what I want to see is this is a little bit tiny, so I'm going to just put it here. So what I want to actually see is that I want each of the ASLCast member to join together to form a cluster so that I get uninterrupted user session. So that a session is shared between all of these and all of the instances, and we see the same session throughout the um, browsing experience. Right, so I have deployed it. The resources, I'm gonna get the ingress so that I can navigate to the application. And here's the application. And what we want to see is we want the session ID to remain the same. How much ever I'm gonna hop around the site. So we just saw that it remains same. Ta-da! This was our goal, that we wanted to make sure that the application works just as fine how it was working on traditional environment. We have migrated successfully to Kubernetes, and it works the way it was expected to work. Um, So I have a couple of takeaways. One of the beauty. So when I started working on this project, what I found interesting was the amount of detail that you can get from the dashboard, the high-level view of the issues, as well as the in-depth detail of as the what is happening and why this issue is caused and what needs to be done, down to the line number of like in the source code where it is actually happening. This comes handy, for example, if you're a architect or a migrator who's planning and you look at the issues dashboard and you're like, okay, I have like 10 issues and like 30 points roughly. And so I can probably get 10 applications or like X number of applications migrated in 1 week. So you can mark them. And as a developer, I could go in and say like, okay, these are the applications. Oh, this is where the issue is happening. That saves a lot of time for me because I could find the line number of where it is actually happening. And it also has the beautiful hint message there. So I can take the hints and just incorporate in the source code. So it makes it much more safer and faster, which I really like. And the second thing is that I recently learned about the custom targets, and that's pretty cool too. So, all for example, take an enterprise which might have custom libraries, right? The one that I could think of is that every company is going to have some kind of a people lookup or employee lookup or something with some photo information about the employee. And there are like say 50 internal applications, and all the applications are using the same custom library. And the company is migrating to cloud. They have invested heavily on Kubernetes and cloud, whatnot. So they want to migrate all the 50 applications that is using the custom library. So what can be done is that they can just take one application and run through the entire process that I showed, come up, if there are any issues, identify the issues, come up with a solution and create a custom target. And then use the target to perform analysis of the next 49 applications or the future applications or the future, use it for the future migrations. So it actually accelerates the migration of the application, and it can be done at scale. So that is the beauty of the custom target. Um, these are the two takeaways I wanted to highlight. And one other important thing is that if you actually like this demo, and if you are a company, or if you're an architect, you're a consultancy, or someone who's actually going through this journey of migration and modernization, and you have use cases and experiences to share, the Conveyor project is actually looking to learn about the experience. We have a wonderful community user group for migration experience where you can just come and share your knowledge or use case. We want to do this so that we can enrich the rule sets so that so many of these issues come out of the box. And if you want to learn more, you can click on the link that I have added a readme to the user group, and there is also more information about the Conveyor community itself, which you can learn by clicking on the link or by asking in this meeting. Either way works. So we have reached the end of the demo. So if you have any questions, please shoot. Either I did a good job or I did a bad job.
No questions, but it was a great demo. Thanks.
All right.
Savita, this was really quick to put together, right? Took you like 5 minutes?
I could just say that, yes.
Nah, I think it was really thought out. A lot of love went into it.
Yeah, I do have a tutorial for this so that I can, I'm working on it, so probably I'll be sharing it, publishing it in the Conveyor website so that can be used by everyone who wants to get an idea of what Conveyor is and how it can help, just to get hands-on experience. So I'll be publishing that soon. So once I have it, I'll bring it back to the community and post it here and in the Slack. So that is up and coming. That is something that we can look forward to. And thank you. I'm going to head back to the agenda, and we have Marek.
Yeah, thanks. Let me share my screen. So this demo will be follow up on what Savita actually showed, and I used their great tutorial how to do that. And we have used the Petclinic application to be part of the test analysis upstream API application tests. So first, this is the issue basically saying that this Petclinic using by Savita's documents and the steps is adding to part of the upstream API test, consists of few PRs. What I would like to show first is maybe the test case definition for this application. So this is just, let's say, more condensed data, which was Savita entered to UI. So we have the Petclinic application, given the repository, rule set with Hazelcast wind up XML file. Then there is part with checks the result or the result report. This is some kind of legacy text checking. Now based on the work with the LSP analyzer integration to the API Hub API, I use the API analysis structures, which should be ready to next time integrate with the LSP analyzer results. But it basically describes the story points and then the issues which are expected to be in the migration or in the analysis. We have a bunch of issues there, and also the list of tags which applications should be tagged in the end of the analysis. As I said, this is partially, it's not really ready for the LSP analyzer, but it's developed in the mind that with having the LSP analyzer in mind that it should be pretty soon integrated with this. Okay, it seems it's running actually. I'm running it against local Minikube installation. So we have currently 3 free task pods. Also, the task seems to be running. We can see that there is the rule set edit is the Petclinic application from Savita here. Speaking about execution, since this is the analysis which can take some time, it was implemented to be parallel. So currently, all three applications which we currently use in the analysis tests in the API are executed in the same time. So the Go test works in the way that when it reaches parallel tests, it just sleeps the test, and then when there are only parallel tests remaining to be executed, it runs all of them. So created applications, created custom rules or rule set with Hazelcast wind-up rules, and then it basically waits until the analysis task is completed. Yeah, some of applications finish a little bit sooner. The Petclinic, I think it's still running. So when the task has finished, the test takes a wind-up report, parses it into the API structs about the issues with the issues and the other things. And in the end, there are some assertions which check if the task returned the correct report or some, let's say, expected data. We can see it passing. So it's here in my laptop. It takes usually about 3 minutes to run. So in the upstream, it's slightly longer because GitHub Actions is like not happy with running this free simultaneous analysis. It's gets killed. So in upstream workflows, it's just serial, but it's no problem, I believe. Speaking about next or integration of this, this is currently part of the Go Konveyor test, which is covered by workflows, upstream side workflows created by Fabian. So since yesterday, since it's merged, it's executed automatically in upstream. About the upcoming work on this, what I'm currently doing is adding the incidents because it's not currently parsed. So we have just issues, so we'll add incidents there. And as the work on integrating LSP analyzer to the Hub API is ongoing, I'm just following it and will update to test LSP2. That's it from me. Any questions?
Just thank you. This is really cool to see. I love the concept of we get the end-to-end demo and then we have it automated inside a test. That is just so awesome.
And thanks, Savita, for providing the really step-by-step demo. Or because it was planned to last community call, I was pretty comfortable with having this description and updating tests for it.
Thank you. Thank you. You're the first person probably to run it through or make it work. I mean, read through the document. So this actually gives me more confidence to publish it soon. Yeah, thank you. Thanks, everyone. Does anyone have any questions for Marek? All right. We have come to the end of the agenda. We don't have any other items, so I'm just gonna wait and see if folks want to bring up any topics. Please feel free to. We can discuss it. This is our time. If not, we can end the call. Meet in 2 weeks.
I have a question. Sorry. So it was about the Hazelcast thing. What was the process of finding out like what version of Hazelcast to use? Like what did you do to get there? To even like get to the rules?
So first I was searching, like when I know that this was not supported in Kubernetes, or it doesn't even know, it doesn't know Kubernetes, what I did was like do a simple Google search on like Hazelcast support for Kubernetes and the dependencies that I can use, and it popped out telling that anything more than anything. They used to have a Hazelcast Kubernetes plugin before, but it's all integrated now. So anything with Hazelcast 5 or above comes with Kubernetes support. So that was super easy to figure out. And
Okay.
the thing to note is that there might be like many ways that the problem that I faced could have been solved. that I just took one route. There are
Mhm.
like many routes. So could have kept the same 4.2.7, but added another dependency, like a deprecated Hazelcast Kubernetes. I didn't want to use a deprecated jar file there. So I went with 5. So it involved a little bit of research. So that's
Yeah.
the
Okay.
thing. Like the first time when you're trying to figure out the rules, or like when you're trying to figure out the solution, it's going to take like the research, usual research, but then use the knowledge to translate everything to rules, which can be like used for future migration.
Yeah. Yeah. It's awesome. Like how much like time that you spend can be compressed into a few lines of rule.
And
Awesome.
when we share it with the community, which means that I would save someone else's time, right?
Yeah. And is there a when you said like when you called out to the community asking them to share rules, is there a convention or is there a place you could share that?
So let me pull up that. I know there is some effort on having rule sets.
Oh yeah, the
Source
conveyor rule
source.
set. Okay.
Yes.
Got it.
So
Got it.
I don't know if the user group readme is updated with it, but I can take that as an action item and see and update it. But even creating an issue with the experience is really valuable and a valid contribution. Don't have to spend the time to write rules. All you have to do is just say, hey, we faced X, Y, and Z while doing this migration, and it might be worth to add a rule about it, or just throw it out as an issue. So one of
Okay. Fair.
team members would just take a look at it and proceed accordingly.
Sounds good. Thank you.
Thank you, Pranav. Did I miss anything on that? Like, do we have anything else on that, John, regarding the rules or contributions?
Nothing else I can really think of except we'd love people to give us use cases. We'll do a lot of the frictional work. Just need use cases.
Yeah. All right. So we have come to the end of the agenda, like I said before. So there is nothing more, and I give you all 5 minutes back, and see you all in 2 weeks. Until then, take care.
Thanks, Savita.
Thank
Take
you.
care.
Bye.